Graphing linear inequalities. A linear inequality is an equation that has x and y variables in it, and it has either a less than or equal to, greater than or equal to. So we're looking at equations with the inequality symbols in it. And that means that there is more than just solutions on the line, that there's a whole area, a half plane, that includes all points that will make the equation true. So here's a picture of a linear inequality. We have a open half plane here. This is open because it's dashed, and a dashed line is similar to an open circle. It means that the points on the line are not included in the solutions. So we call that open. And then the half plane is the half of the graph that is shaded. So we're going to look at which points are solutions to the inequality graphed here. So for each point, we're going to put it on the graph and see if it's in the shaded region. If it's on the dashed line, it won't be a solution. If the line were solid, it would be called a closed half plane, and it would be a solution. So let's look at 0, -2. 0 on the x, -2 on the y, not a solution. -4, 0, that's the second one, so -4, 0 is a solution. -2, +1, that's on the dashed line, so it is again not a solution. 0, +4, it's in my shaded region, so it's a solution. -5, +2 in the shaded region, so it is also a solution. +1, -2, not a solution. -4, -2 on the other side, not in the shaded region, so not a solution. -5, -2 is on the dashed line. When it's on a dashed line, it's not a solution. And 0, 0 is not a solution. So the 3 points that are circled are our solutions. So can we check a point and plug it into the equation to see if it's an inequality? So we have 4, 5. Is that a solution to y is greater than or equal to 2x minus 7? So remember that it's x, y. So I'm going to plug in 5 for my y. Is that greater than or equal to 2 times 8 minus 7? I don't know why I put 8 in there. Let's fix that. 2 times 4, which is 8. That's why I put that in there. Is 5 greater than or equal to 1? Yes. So it's a solution. What about -2, 1? Is it a solution to y is less than ½ x minus 2? So 1 is less than 1/2 times -2 minus 2. 1 is less than 1/2 times, or 1/2 times 2, is -1, minus 2 is 1 less than -3. No, 1 is not less than -3, so it's not a solution. Let's do an example with this one is, let's see, 2, -1, a solution. So -1 less than 1/2 times 2 minus 2 is -1 less than 1 minus 2 is -1 less than 1, -1. So remember that when it's not equal to, -1 is not less than -1, it's equal to, so here it's not a solution. And what if it's in standard form? Can we still figure it out? Plug in 1 for x. 4 times 1 minus 3 times 3 is greater than or equal to 2. That's 4 minus 9 is -5 greater than or equal to 2. No, so it's also not a solution. So now let's graph them. We're going to graph this inequality. If it's here's some steps. If it's not solved for y, we're going to have to do that first. In this case, it is solved for y. We're going to graph the equation, and when we do that, we're going to use a solid line if it's less than or equal to, and we'll use a dashed line if it's less than or greater than. So my y-intercept is at positive 4, and then my slope is negative 1/3, so I'm going to go down 1 and over 3. Down 1 over 3. And I'm going to use a dashed line. And then I need to figure out where to shade. So I like to check the point 0, 0 and see if it's a solution. So we're going to check it. If it's a solution, we'll shade on this side, and if it's not, we'll shade on the other side. So is 0 greater than negative 1/3 times 0 plus 4? Is 0 greater than 4? No. So the solutions are not on the same, that side of the equal sign, or the line. They're on the other side of the line. So I'll shade here, above the line. And the shortcut really is, if it's greater than, we'll shade up, and if it's less than, we'll shade down. Okay, we're going to solve this equation for y. Minus 3x, 5y less than or equal to negative 3x plus 40, divided by 5. Y is less than or equal to negative 3/5 x plus 8. Remember, with inequalities, if you divide or multiply by a negative, the inequality flips. By a negative. Okay, so we'll start our y-intercept 8. And our slope is negative 3/5, so down 3 over 5. Down 3 over 5. And it's less than or equal to. Less than or equal to, so we're going to make it a solid line. And then let's check to see if 0, 0 is a solution. So is 0 plus 0 less than or equal to 40? Because 3 times 0 is 0, and 5 times 0 is also 0. So yes, 0 is less than or equal to 40, so we'll shade on this side of the line. Make it bigger so we can shade faster. So 0, 0 is a solution, so we'll shade on the same side as 0, 0. And this is a closed half plane, so the line is solid. And again, the shortcut is, if it's less than, we shade down, and if it's greater than, we shade up. The next one is x minus y is greater than 5, so subtract x. Negative y is greater than negative x plus 5. Now we have to get y by itself, so we need to divide by negative 1. And when we divide by a negative, we have to flip our sign. Y is less than positive x minus 5. So my y-intercept is negative 5. Start at negative 5 on the y-axis. And my slope is up 1 over 1. So up 1 over 1. And it's just less than, so it's going to be dashed. And we'll check that point 0, 0. We can always check 0, 0. I use 0, 0 because it's the easiest to use. The only time we can't use it is if it's actually on the line. So is 0 less than 0 minus 5? Is 0 less than negative 5? No. So we would shade under the line instead, because 0, 0 was up here. We want to shade on the opposite side of the line. And this one's called the open half plane because the lines are dashed. Remember that your x equals equations, x equals a number, are vertical lines, and your y equals a number equations are horizontal lines. And so we'll draw that the same way. It's just greater than, so it's an open dashed line, vertical, and is going to cross where the x's are all 4. And then again, let's check the point 0, 0. 0 is greater than 4? No. So I want to shade to the right, because those are where the x's are greater than 4. That should make sense. Look at your number line. 5, 6, 7, those are greater than 4. And then we'll graph y is less than or equal to 2. That's a horizontal line. It's going to be a solid line. And less than 0, 0 is 0 less than or equal to 2. Yes. So we'll shade where it's less than, where 0, 0 is. Less than would be down in this case. And then here's one that stumps all of our students all the time. Y is less than x. So let's remember that this means 1x plus 0. So we start at 0, 0, and we go up 1 over 1. And it's dashed because it's not equal to. And then here's the point where I can't use 0, 0 because it's on the line. So I'm going to check a different point, maybe 0, 1. So that's this point here. Is 1 less than 0 plus 0? Is 1 less than 0? No. So my solutions are on the opposite side, which again, if we look at the up and down, that would be considered down from the line. And so that's where we shade.